Now let us do one more example together. In this case, we have a binary tree to be built with the order of 3, which means it is going to have maximum of 3 children and maximum of 2 values inside each node. So let us have it here. So we have it 10, okay, and 20, okay. Now, when we try to insert 25, node split will happen. So node split will create a node like this. Okay, so here I am going to add 25. Just make sure that they are all in ascending order because the middle value is very important because it becomes a new root now. 20 and then this is 10 and here 25 is your right child. So we inserted this and this. Insert 35. 35 can be easily inserted because it will check with the root 20 greater. It is greater than 20, so it comes here. When now 40, okay, 40 is greater than, checked at the 40 is checked at the root node. It is greater, sent to the right node. So here there is a node split required. Okay, whenever there is a node split, the middle node it is adjusted by moving it to the root, and in the root we have a space to accommodate 35. So the new tree will look like this: 20 and 35. Okay, now this 35 is going to make this 25 as the middle child of them, and 40 as a right child, and 10 remains unchanged. Okay, so let me make some space. Now this is the new tree structure after inserting 40. So we inserted 40, 40 is inserted, 5 has to be inserted. So 5 is checked at the root and then it is sent to the left child. 5 inserted, now 6. We have to insert 6. So there is a node split going to occur. And before we put the node split, we have to, 6 here, right? But we have to just quickly arrange the internal values so that your new root can be picked up. So 6 is going to be pushed up. Now 6 will come here. Again, a node split happens. What is the new root? New root is going to be 25. Okay. So, sorry, 20. Okay. So we have 20 as the new root and its left child is going to be 6. Its right child is going to be 35. 6 is going to have 5 as the left child and 10 as the right child. Okay, where is this one has to be there, right? Okay, so 25. Now 25 will become the left child of 35 and the right child is going to be 40. Okay, so did you understand? Now, when we try to insert 6, it created a node split. So we try to adjust it in the root. Root, when we try to do that, this is also causing a node split. So 20 become the root, and then 6 will become the left child and 35 will become the right child. Now, as soon as the left and right child is changed, this 25 has to be adjusted, right? It cannot be adjusted with the 6th, value because it is greater than 25. So it cannot come here. It cannot come in this subtree. It has to be moved to the right subtree. So it is moved to the right subtree, but less than, because it is less than 35, it became the left child of 35. Okay, so done with the 6. 9. Now we want to insert 9. 9 is checked here. 9 is less than, so it is sent to the left side. 9 is checked here. 9 is greater than 6. So I can put 9 directly here, but that is wrong because I have to start filling my leaf nodes first. So 9 here. Make sure that they are in ascending order. Okay, so 9 and 10, we inserted 9. So I just want to remove the extra values so we don't get confused. Okay. Okay. So we have inserted 9 also. Now we have to insert 10. So 10 is checked here. 10 is less than 20. 10 is checked here. Okay. So why will I not put 10 itself here? Because it is not allowed. The leaf has to be, you know, filled first. When the leaf is full, then I can put this 10 value in the internal node of 6 beside 6. Okay. So 10 is greater than 6, right? Then the 10 is sent here. Now I check that this node is not having space anymore. So what will I do? I will arrange 9, okay, and 10 and 10. Okay, so the middle value will go up, and here we have 10, and then now this will reconstruct, this part will reconstruct. So I have 9 as a middle child, and then 10 as the right child. Okay, so this is how the tree is given 6 and 10. Okay, so let's see, it's 26 and 10, 35, 5, 9 and 10, and 25 and 40. Let's check it. So uh, give the annotation. Now the values. Okay, so we are going to enter 20, insert, and then we are, sorry, delete this one, clear. The first value is 10, right? So we are going to insert 10, and we are going to insert 20, and we are going to insert 25. You see how they are registered? Okay, then we are going to insert 35. 35 is checked here and sent to the right, and then kept inside the right child. 35. Then we have to insert after 35, we have to insert 40. Okay, so here, then we have to insert 5. Then we have to insert 5. And then we have to insert 6. Okay, yeah. And then we have to insert 9. So it will come here. And then I have to insert 10. Yes, so you see 20, 6 and 10, 35, and it's having 5, 9 and 10, 25 and 40. Okay, so done with this now. I will just keep it in the slide. Yeah. So, okay, so this is our correct one. Okay, now you should be able to create the binary tree on your own. Now, in the exam, we can ask you a question to draw the tree from the beginning, or we can give you some values and we can say we want to add, for example, I can give you this, let me make it bigger so you understand. I hope the screen is being shared. Okay, so trying to make this bigger. I want this. Okay, so just trying to make it bigger. Now, we can give you a question wherein we can ask you to draw the tree from the scratch, okay, from the first point by giving some values like this. Or we can give you a tree like this and and we can give you some more values to insert inside it. For example, I can give you, for example, more values like 20 and 30 and 40. So we will ask you to insert new three values inside the tree, and we'll ask you how the tree will look like after inserting these newly added values. Okay, so that can come, and you have to check that you insert these new values properly inside the existing tree. So these are the two type of questions that can come in the exam. This tool is very effective, very useful for you to verify whether you have drawn the tree correctly or not. So done with this. Okay, so we don't need, okay, I'll delete this one. Now do these examples by your own. Okay, draw the tree and check if the answer looks like this. Draw this tree and check if the answer looks like this. Okay. Now I will stop and will do a new video for deletion.